Reality updates. Planck, what if I told you that the smooth, continuous flow of your life, the seamless way one moment melts into the next, is a complete and utter illusion? We perceive reality as a pristine, high-definition movie, an unbroken river of time carrying us forward. But what if, beneath that polished surface, the universe operates more like an old, flickering film reel? What if existence isn't a continuous stream at all, but a series of distinct, individual snapshots, flashing into being one after another at an unimaginable speed? This is the concept of a cosmic frame rate, the unsettling idea that reality itself updates in discrete, measurable steps. It suggests that the very fabric of space and time is pixelated, granular, and fundamentally digital. And if that's true, it opens the door to a possibility so profound it borders on terrifying. What if the universe's update speed is finite? What if it has a processing limit? And what if that limit means that reality itself struggles to render its most fundamental component, light? To even begin to grasp this, we have to journey down to the absolute bedrock of existence, to a scale so small it defies all human intuition. We need to talk about the work of Max Planck and the revolutionary idea he introduced to the world. At the turn of the 20th century, physics was grappling with a problem called the ultraviolet catastrophe. Classical theories predicted that a perfect black-body radiator should emit infinite energy, which obviously doesn't happen. Planck solved this by proposing something that seemed absurd at the time, that energy wasn't continuous. He suggested it could only be emitted or absorbed in discrete little packets, which he called quanta. This was the birth of quantum mechanics, and it was the first major clue that the universe might not be as smooth as we think. From this, physicists derived the most fundamental units of measurement possible, built from the constants of nature itself. One is the Planck length, about 1.6 times 10 to the power of minus 35 meters. It is the theoretical smallest possible distance. To put that in perspective, if you were to scale up an atom to the size of the entire observable universe, the Planck length would be about the height of a single tree. It's the pixel size of reality. Any smaller than that, and our concepts of space and distance completely break down. But if space has a smallest pixel, then time must have a smallest tick. This is known as Planck time. It is the time it would take for a photon, a particle of light, to travel a distance of 1 Planck length. Its value is about 10 to the power of minus 43 seconds. This is the shortest possible unit of time that has any physical meaning. It is the shutter speed of the cosmos, 1 tick of the universal clock, 1 frame of reality. In the time it takes you to blink, the universe has updated, has rendered a new frame of existence trillions upon trillions upon trillions of times. This frame rate is so mind-bogglingly fast that it creates the perfect illusion of continuous motion, the same way a 60 frame per second video game looks perfectly smooth to our eyes. We are simply incapable of perceiving the individual frames because they happen on a timescale so far beyond our biological or technological comprehension. This idea that reality is granular isn't just a philosophical musing. It's hinted at by the strange rules of the quantum world. Think about an electron orbiting an atom. We're taught to imagine it like a planet orbiting a sun, a smooth, continuous path. But quantum mechanics says this is wrong. An electron exists in specific energy levels, or orbitals. When it moves from a lower energy level to a higher one, it doesn't travel through the space in between. It performs a quantum leap. It is here, and then it is. It ceases to exist in one location and instantly begins to exist in another. This instantaneous, non-continuous movement is a profound clue. It's as if the electron's position is only calculated or rendered at specific, allowed locations within the cosmic code. It doesn't need a path because the concept of a smooth path is an illusion of the macro world. At the fundamental level, there are only states, frames, and updates. The universe is a grand calculation, and in one frame the electron is here, and in the next, the calculation places it somewhere else. So, we have a universe built on pixels of space and ticks of time, a universe that updates. This naturally leads to the ultimate question: how fast does it update? The obvious answer seems to be at the speed of light. We're always told that the speed of light, c, is the ultimate speed limit of the cosmos. Nothing can travel faster. It's the speed of causality itself. Information cannot propagate from one point to another faster than light. So, it's logical to assume that the update of reality spreads out at this maximum possible speed. But here is where our minds must take a sharp, terrifying turn. What if that's not the whole story? What if the speed of light is merely the fastest speed a rendered frame can move, but the process of rendering that frame is governed by a different underlying mechanic? Imagine the universe is a vast cosmic computer. The speed of light is the maximum speed a character or object can move on the screen. But the computer itself has a processor speed, a clock cycle. It has to compute the next state of every single particle in the universe before it can display the next frame. What if the information required for that computation, the state of the universe data, propagates at a speed that is fundamentally limited? This leads to the horrifying core of our question. What if the cosmic frame rate, the update speed of reality itself, is actually slower than the speed of light? This seems like a paradox, a logical impossibility. How can anything be slower than the thing it's creating?
But it's not about light outrunning reality. It's about the very fabric of existence lagging behind its own potential. It means that light isn't traveling through a pre-existing space. Instead, the movement of light, the creation of space, one Planck length at a time. And if the system that dictates where the light particle goes in the next frame has a processing delay, then the propagation of light itself would be bound by this ultimate underlying bottleneck. The universe wouldn't be a river, it would be a cosmic traffic jam, and even light itself would be stuck in it.
Quantum proof, simulation. So this idea of a lagging reality, a universe that has to buffer its own existence, sounds like something ripped from the pages of a Philip K. Dick novel. It's speculative, mind-bending, and deeply unsettling. But are there any whispers of it, any faint, ghostly echoes in the halls of actual physics? Or is it pure science fiction? While there is no definitive experiment that proves reality has a frame rate, there are bizarre quantum phenomena that fit unnervingly well with this picture. The most famous of these is the Quantum Zeno Effect, sometimes called the watched pot never boils effect of the quantum world. In simple terms, it describes how the act of continuously observing an unstable quantum system can prevent it from changing or decaying. For instance, if you have an unstable radioactive atom that's about to decay, the laws of probability tell you when it's likely to do so. But if you could measure or observe that atom continuously, checking its state millions of times a second, you can effectively freeze it in its undecayed state, preventing the decay from ever happening. How is this possible? From a standard quantum mechanics perspective, every measurement collapses the wave function, resetting the clock on its probability of decay. But let's look at it through the lens of a cosmic frame rate. Imagine the atom's state is being calculated frame by frame. In frame 1, it's undecayed. Frame 2, undecayed. In each frame, there's a tiny probability that the universe's calculation will result in decayed. But when you observe it, you are forcing the cosmic computer to render the state of that specific particle. You are pinging the system, asking, what is its state? By doing this in rapid succession, you are essentially forcing the system to re-render the over and over. You are locking it into a computational loop. The system is so busy responding to your continuous queries, is it decayed yet? How about now? Now? That it never gets the computational cycle free to actually execute the decay subroutine. You are, in a very real sense, DDoSing the universe to prevent an event from happening. The Quantum Zeno Effect doesn't prove reality is discrete, but it's a tantalizing piece of evidence suggesting that time and change might not be the smooth, inevitable forces we imagine them to be. They might be processes, calculations that can be interrupted. This idea of a computational universe leads us directly to the most profound and popular interpretation of these concepts, the simulation hypothesis. The argument, put forth by philosopher Nick Bostrom and others, is simple. If any civilization ever reaches a point of technological maturity where they can create ancestor simulations, simulations of their past so detailed that the beings inside are conscious, they would likely run billions of them. Therefore, it is statistically far more likely that we are one of the countless simulated beings than the single original base reality. A cosmic frame rate, defined by Planck time, isn't just compatible with this theory, it's practically a requirement. Any computer, no matter how powerful, operates on a clock speed. It processes information in discrete steps. It has a finite resolution. The discovery that our universe seems to have a fundamental pixel size and a fundamental clock speed is precisely what you would expect to find if you were a character waking up inside a video game. Our laws of physics aren't just descriptions of nature. They could be the lines of code, the algorithms that govern the simulation's engine. The speed of light isn't a cosmic speed limit. It's the maximum rendering speed of the processor. If we accept this chilling possibility, the consequences are staggering. Our entire understanding of causality gets thrown out the window. We experience cause and effect as a linear chain. A happens, which causes B, which causes C. But in a simulated frame-based reality, that's just an illusion. A causes B. Rather, the state of the universe in frame 1 is fed into a cosmic algorithm, which then computes the state of the universe for frame 2. Our perception of causality is just us experiencing the logical progression of the underlying code. Free will itself becomes a question mark. Are we making decisions, or are our conscious thoughts simply the output of an incredibly complex calculation that was set in motion at the simulation's dawn? Even our own consciousness, that ineffable sense of I, could be an emergent property of this cosmic computation. Just as complex patterns emerge from simple rules in Conway's game of life, perhaps our subjective experience is the high-level result of trillions of simple Planck-scale calculations clicking forward frame by terrifying frame. This brings us back to the ultimate cosmic lag. The idea that reality updates slower than light could be an interpretation of a limitation of the simulation's hardware. Perhaps the universe is so vast, so complex, that the system running it struggles to keep up. The speed of light, c, might be the theoretical maximum speed allowed by the software, but the hardware can only process the propagation of that light at a slightly slower rate. We would never notice this discrepancy directly because all our measurement tools, our bodies, our very thoughts are made of the same system and are subject to the same lag. It would be like a character in a video game trying to measure network latency using the in-game clock. It's impossible. But this cosmic buffering could manifest in other ways. Could it be the source of quantum uncertainty, the universe's way of cutting corners and using probabilistic shortcuts to save on processing power? Are dark matter and dark energy simply artifacts of the simulation, placeholders or rounding errors in the cosmic code? We are left with the unsettling image of our existence as a grand cosmic computer program, one so massive that even its creators can't make it run perfectly smoothly. We are living in the lag.
So, the next time you experience a moment of strange coincidence, a glitch in your perception, or a fleeting sense of déjà vu, pause for a second. Ask yourself, is it just your mind playing tricks on you, a random firing of neurons? Or are you, just for a fraction of a second, perceiving the truth that the universe just dropped a few frames?